Hello, this is Instructor Rick Powers from Western Technical College, Basic Statistics. Lesson 28A, Confidence Intervals, Bootstrapping. Bootstrapping is a method in statistics which is an unusual tool for analyzing data. As in the other methods, we start with sample data and we get information which we hope will tell us something about a population. However, bootstrapping is a method which does not have as many assumptions about the shape of the population as the other methods. If we call those assumptions parameters, then bootstrapping is a non-parametric method. What is bootstrapping? In statistics, it refers to a way to take a sample and use it as a substitute for population information by using random selection of the numbers from the sample. There's an old saying, pull yourself up by your bootstraps. It means that you don't get any outside help. It's just you helping yourself. Technically, if you have straps on your boots and you try to pull yourself higher, you won't get anywhere. This method in statistics uses the idea that we don't really know what the population looks like, but we know what the sample looks like. So why not use what we have and not worry about what we don't know? We will use the sample to make an artificial data set, which looks like a set of samples from a population. The method is to choose data values with replacement from the sample. It's like having a set of numbers in a hat. Traditionally, everyone talks about picking numbers from a hat. We take out a number, record it, put it back into the hat, and then select again. We randomly select values from the sample data set, and we record the results in order to have a large number of artificial samples, each with the same number of measurements as the original sample. We are making bootstrap samples, which are randomly chosen from the original sample with the same sample size as the original sample. If we calculate some number, such as the mean, for each bootstrap sample, then it's like a randomly chosen number from a list of available choices. It can be higher or lower than the original sample mean. So having the bootstrap samples will be similar to having a set of random samples from the population. This is not a traditional method in the normal sense. It was developed in the 1970s and became widely available with the use of computers. Most other statistical traditions go back to the 20s and the 30s. So why use it? As we've said earlier, the mathematical methods of the traditional ways are based on bell-shaped data. So there are two situations where bootstrapping might be useful. Number one, if we know that the population data is not bell-shaped, then we can still get some useful information. And number two, if we don't know anything about the shape of the population and our sample data is messy, skewed, or having outliers, then once again, we can still get some useful information. One example that I found is a description of analyzing measurements in nuclear power plants, where each plant will have unique inputs and variations. Bootstrapping does not require knowing everything about the population, so that can be a useful tool in dealing with new situations. One important note of caution: if the bootstrapped distribution turns out to be in bad shape, meaning that it's not bell-shaped at all or having a lot of gaps or clusters of data, then we should not trust it to give good results. These types of decisions rely on experience with the method and with the data used. Be sure to watch the videos provided regarding the use of StatCrunch or other software in using bootstrapping methods. End of lesson 28A.